Hey guys, welcome. Sorry I couldn't be there today, but thank you for watching the video. Make sure you pay very close attention to the entire video because at some point in time I'm going to throw something in there that I need you to remember. This is a secret between you and I only. Don't tell any of your other classmates, especially the ones that you know probably won't pay attention to what's going on in the whole video. So this is your warm-up. Go ahead and pause the screen now and copy down all the questions. You don't have to draw the graph, but um, work it out, have it on your paper. So I know you just paused the screen and now you're back. So I'm going to put up the answers. Alright, so these are the answers to those questions. The first graph shifts to the right 3 because of that, and up 2 because of this one. Okay? The range of the graph for this one, well, this is an exponential function, and even though it shifted right 3, we don't really pay attention to that. It would normally start at 0 and go up, but since we've shifted it up 4, it's going to start 4 up, so it'll go from 4 to infinity, and that's why the y's are greater than 4, and it's from 4 to infinity. It cannot equal 4 because when we have it normal, if this 4 wasn't here, it would be at 0, like down here, and then go up, but it would never actually touch 0. So that's why it doesn't include 4. Looking at question number 3. So when we want to write it like this, basically you want to figure out what do you have to do to get from negative 3 to positive 4. And so to get from negative 3 to positive 4, you add 7. Okay? Alright, for this graph, it says we have f of x and g of x. Here's f of x, here's g of x. And it says, what is the function rule for g of x in terms of f of x? Okay, really you just need to figure out how this graph has shifted. There's two ways you could look at it. You could look at kind of where it asymptotes right here and figure out how many spaces it went up. 1, 2, 3, 4 up. Or you can look at the y-intercepts, okay, and see that it also goes up 4. It's really difficult to tell whether it shifted, but you can basically tell by looking at the gap here and here, and here and here, whether it shifted left or right, and it hasn't, since these pretty much line up the same spacing all the way across. It hasn't really shifted at all. So this is your objective for today. We're gonna talk about solving compounding continuous interest problems for the missing variable. We'll go through your notes and you'll get some practice. We're also going to practice some of the older things that we've done here. So if you need to pause to write this down, go for it. If by chance the sub has not given you the papers, will you tell the sub that there are some colored sheets on the second shelf down on the right side, near my desk on the bookshelf, and there should be some colored paper over there that has the warm-ups on it that she can give you. Alright, so this is bringing it back to the other questions that we were doing before. This is just simple growth function equation. Your general equation here is y equals, or excuse me, sorry, we did the amount is the principal times 1 plus r to the t. Okay? So just pause the video now, see if you can do this on your own, and then when you unpause it, it should pick right back up with us solving the question. Okay? So this is our initial year, this is our initial amount is our p, so we got 42208, okay? And we have 1 plus, and then our rate of growth is what we don't know, so that's going to be our R. Our T goes from 1999 to 2016, so that'd be 16 plus 1 more, which makes 17. And then we know our final amount is 60,000, okay? And so what we need to do is just solve this equation. So the first thing you would do is divide by the 42208, 208. Okay? And so you get 1.4215 equals the 1 plus r to the 17th. Okay? And so now you do the 17th root of that number, 1.4215, and that's going to equal 1 plus r. That equals 1.0209 equals the 1 plus the r. Subtract the 1, subtract the 1, so you get 0.209 equals r. So our rate of growth for this would be 2.1% roughly. Okay, I just take this, you move the decimal 1, 2 over, and then 0.9 makes that round up to 1. You could have just left it at 2%, and you should have been able to figure that out. Okay. Alright, so we're looking at this. We're looking for the key words, so one of y'all might ask, well, how do we know to use that formula and not the compound interest formula? So what you're going to be looking for is, does this have the word compound in it? If it doesn't, just use the normal growth function. If it does say compound, then you need to go to the one that has the 1 over n and the n to the t. Okay? So this one is the initial amount starting in 2005, and then here's the secondary amount in this year. That's 10 years different. So what is the value of the house in 2018? So now that's asking for 3 more years. So what we have to do is we have to find the rate, and then we have to plug it back in using the initial amount. The fact that we're now going to go 13 years with the new rate that we found. So it's the two-part process. So part 1, find the rate. Okay, and so you should be able to do this on your own. I forgot to tell you to pause it, but go ahead and pause the video and see if you can do it on your own, and then come back and double check. Devin, go ahead and pause that video. Thanks, buddy. Alright, so the initial amount is 22,500, and we have 1 plus r to the t. Well, the t here we said was 10, and that's going to equal the 356,000. Alright, to solve this, we must first divide by the 22,500, oh, excuse me, 225,000 to both sides. Okay. Ended up with 1.582 repeating equals the 1 plus r to the 10th power. So now you'll do the 10th root of 1.582, and then that's going to give you the 1 plus r. Okay, and that gives you 1.0469 equals the 1 plus r. Okay, now I used the exact value that I got from up here when I did this, and that's my suggestion for you guys to do as well. But then you subtract the 1, and you get 0.0469 equals r. So then that would be roughly 4.7%. Okay. So the next question, go ahead and pause the video and see if you can figure out the question on your own, and then when you unpause it, we should be solving. Okay, the key about this one is you see the word compounded, and then you see quarterly. Quarterly means 4 times. Okay, so that means here we know n equals 4. We know we're going to use the a equals p times the 1 plus, and now you're going to do the rate over n, and then the n times the t. Okay, and so we know our n is 4. Okay, and then we have $5,000 that you're in This is telling her that she has $5,000 at the end of investing an account. So this is our A. Okay. And then we know our R is the 0.013. Okay. And then we know our T equals 1.3. So we're trying to find P. So P is the part that we don't know. Okay, so we go in and we plug all that in. So we've got $5,000 equals the P times the 1 plus 0.013 over 4 raised to the 4 times um, 5. And I don't know why I did 1.3 down here. I sincerely apologize. I hope you caught that. It should have been 5. I don't know why we're at 1.3. Our time was 5 years right there. Okay? And we go through it and we solve that. Okay? So you get $5,000 equals P times 1.0325 raised to the 20th. Okay? And then there's two routes you could go. You could go ahead and do this and then divide by it, or you could just divide by the whole thing. Your calculators are so fancy now that you can just divide by the whole thing and not have to worry about it. Just make sure you use parentheses where appropriate. Okay? And you'll notice I had left off an extra 0 in there. I'm sorry, so I'll put it back in. And you would have 4,685.83 is what P equals at the end of that. Okay? And you should see that the interest was 1.3%, so you're not going to be increasing that much, especially in only 5 years. And so that should seem pretty reasonable, but it's only going to go up about $315, 14, somewhere in there. Okay? Alright, so go ahead and pause the screen, work this question out, make sure you know how to do it, and then when you unpause it, I'll get to solving it. Alright, so it does say compounded, and it says monthly, which means our N equals 12. Okay, our rate is 0.019 right there, and then we want it to double, so our time, our principal, and our amount. So our principal is 3,000, and we want it to double, which makes it 6,000, and then we want to know how long will that happen, so our T is unknown. Okay, so A equals P times 1 plus R over N to the NT. Okay, and we get 6,000 equals 3,000 times 1 plus the 0.019 over the 12 raised to the 12t. Okay? Alright, so this is one that we're going to end up having to use a log to solve because we have a variable in the exponent. Okay? First, we'll go ahead and divide this over, and you'll get 2 equals 1 plus the 0.019 over 12 to the 12t. Okay? One of the things you may notice is anytime we talk about doubling or tripling, eventually it's just the percentage point part, and 2 if it's double, 3 if it's triple, quadruple is 4, because that number and that number, the initial amount and the doubled amount, will always divide and give you back 2, 3, or whatever it was that you were doing. So that's a little shortcut if you're doing one of these questions. Just put that number down and then do your actual percentage part with the correct exponent, and then you should be good to go. So now we have a variable in the exponent, and we have just the exponent term isolated because it's the whole parentheses raised to the variable exponent. And so now we'll do the log to get rid of it. So it'll be log with all of that in the base, 1 plus the 0.019 over 12 to the, and then our new thing is 2 right there is going to equal 12t. And then you can divide by 12 to both sides, and t equals, and you should get 36.5 years. Alright, so just using your calculator, take a moment, and I want you to just type this part in, and then everywhere you see the letter N, I want you to plug in 10, then do 100, then do 500,000, and then pick larger and larger and larger numbers. But make sure you round to 8 decimal places. So there's 10. We'll just put the answer right next to each other and go. And just keep going 8 decimal places. So you should try 1,000,000. Maybe 5,987,423. I don't know. It doesn't matter. Just keep going and going and going. You come up with your own numbers. Keep going. Go up really high. Okay? Pause the video. Fill in the blanks. And then when you're done, can continue the video. What you'll start to see is that the number, after I did all these numbers and entered in, is that they all start zoning in on this one number right here. And it's basically this number right here. It's just like the number pi is this irrational number that shows up all over the place. E is this special number right here. And it comes from doing that towards infinity. And so it's a special number we use for continuous interest. Okay? It is accredited to Euler. That's why we use the letter E. But Bernoulli was a mathematician. He's famously known for Bernoulli's principle. He used it in compound interest, and that's why we're going to use it here. And he just figured out that instead of doing normal compounding, if you just did it continuously, it would give you a little bit more interest, but not so much more that it would matter. And so we get the new formula that we're going to use. Now, the continuous compounding formula, or the PERT formula. So P and A are still the same, the amount after time and the starting amount, or the principal. E is the Euler constant. That's actually a button in your calculator. If you pull your calculator up, it is the E to the X button right here. And you can get to it by going second and then ln. Okay? And it'll give you E to some power. Okay? Rate is still the same, time is still the same, those things are the same. The one thing that you need to understand, though, is we're going to start talking about this more in the next lesson, is the inverse of E is the natural log, or ln, and that's the button that you had to click to get there, that button. So log is base 10, ln is base E. Okay? So make sure you copy this down. This is super important. Make sure you have this. Okay? And you can pause because I'm about to move forward. Okay. So you have this compounding continuously question. Okay? This will be your first example for compounding continuously. So you invest $250 in an account compounding continuously at a rate of 1.2%, which is about a typical bank account, maybe a savings account. And then what is the amount in the account after 5 years? Okay, and so we go A equals 250 e to the 0.012 and then times 5. Okay, and then pull up the calculator and you just type in, let's go to the front, 250 e and then 0.012 times 5, press enter, and you end up with $265.46. We always round two decimal places when we're talking about money, and so there you go. And then let's just compare that to the compounding. Let's say you compounded quarterly for this one. So you would get A equals 250. You won't see significant gains, but you'll see some gains. And then you've got the 0.012 over 4. And then you got 4 times 5. Okay, so we'll just go straight to the calculator, and you can see it here. That if you go 2501 plus 0.012 divided by 4, oops, close the parentheses the other way, up, and I'm going to go ahead and make that 20. You would end up with $265.43. I think it was 43, 44. And so you look and you only make 2 cents more this way, but now you don't have to worry about whether it's compounded quarterly, monthly, etc. It was easier on the banks to just do it this way. So that's one of the things they did. They actually did it more for when they were going to be receiving interest than when they would be paying you the interest. And it was just another way for them to get more money. So it's your turn. So this is looking, actually, it's our turn. This is looking at, you're given the formula and you want to figure out the year that it's going to be half the initial amount. Okay, so we know it's going down because this is kind of like a decay. You see the negative, that's how you would do the decay continuous function. But all you need to know is that you have the function here. Oh, e to the negative 0.9, the 0.099t. Okay, and when we do this, in order to solve it, first we have to isolate the e term. Okay, and then our p, we need to know, is 1/2 of that amount. So half of 600,000 would be 300,000. Okay. The same shortcut applies that I talked about earlier, because you'll see that we have to divide the 600,000 to the other side, since we want the number to not be double or triple, but we want it to be half. When we divide the 600,000 to the other side, you'll end up with 0.5 equals e to the negative 0.099t. Okay, so the inverse of e is the natural log. That's the ln. Okay, is the e inverse function. Okay, it's not e to the negative 1, but it's the inverse function of e. Okay, or it's the e inverse. Okay, so that means we would do ln of 0.5 equals negative 0.099t, and then we would divide by negative 0.099 to both sides, and t will equal, pull the calculator up, ln of 0.5 divided by negative 0.099 equals, and then you get 7. So the t equals 7. I'll pull that back up so you can see what I did. This one's actually easier than the log because you don't have to worry about chain of base or anything like that because it's always to the base e. You will use natural logs more in pre-calc and calculus. It comes into play quite a bit in those two classes. Alright, so you have this one. Let's do that on your own. Pause the video and then come back to me. Okay? Alright, so hopefully you've paused the video. So basically this one says double. We can use that shortcut. And so we know 2 is going to equal e to the 0.099t. Okay? If you need to see that, it'd be 900,000 equals, because that's double 450,000. And then you still have e to the 0.099t. Okay? And then you inverse the function, so you get ln of 2 equals 0.099t divided by 0.099, and t will equal the natural log of 2, close my parentheses, divided by 0.099, bam, 7 years again. Okay? Any questions, comments, or concerns? Haha, can't answer that. Alright, so these are your practice questions. Go through and answer them. Pause the video. Come back. I'll show you the answers. Okay? And then shortly after this, I will also give you the extra tidbit that I'm going to ask you for the next day to see if you actually copied it down to C, because it's an addendum to our synthetic division to make sure you have all synthetic division done correctly for every situation there possibly could be. So make sure you get the extra notes after you do this as well. Okay, so you've paused the video. I know you did. Oops. And you're ready to move forward. So we have $400,000, $400, and we're doing it continuously. So that's going to give us the e to the 0.015 to the 10th power. And we want to know what is the amount after. So we're looking for the a. So you're going to just type that in, 400 times second that, and you got 0.015 times 10, and you press enter, and you get $464.73. Okay, very straightforward. Okay, so we want to know how long will it take this one to triple $500. Okay, so you could write the 1500, okay, equals the 500 times e to the 0.022t. Okay, or you could just go straight to this step, e to the 0.022t. Okay, inverse log, so you get the natural log of 2 equals the 0.022t, and then t will equal the natural log of 2 over 0.022. And so we do that, natural log of 2 divided by 0.022, and then bang, we get t equals 31.6 years. I think that's what it was, 6. Nope, 31.5. Okay. Years. And I put dollars. No, it doesn't make any sense. Okay. And then lastly, we have this question here. So it gives us our formula, okay? Um, and then it wants to know in what year will the population double the initial amount. So I'm going to go straight shortcut on this one. If you need to see, just double that. It'd be 1 million equals that. Okay, so 2 equals 500, oh, excuse me, 2 equals e to the 0.097t. Okay, and then we'll do the natural log of 2 will equal 0.097t. Okay, and then we'll divide by 0.097, and so t will equal the natural log of 2 parentheses divided by 0.097. It's going to be close to 7. Yeah, 7.14 years. Okay. Alright. So, the new part that we got to talk about is an addendum or an additional piece to the synthetic division. Okay? Four x cubed minus 8x squared plus 7x minus 11. Sorry, I meant to have that paused for you. I shouldn't have been playing the whole time. I meant to pull up a question um, while it was paused. Um, so I'm sorry you had to wait through me looking up the question. I meant to have it paused so I could have it up on the screen for you. So synthetic division is still going to work the same way it always has. There's just an additional piece we have to do when you have a question that looks like this in the end. Okay, so if we have a lead coefficient right here on the x, there's an additional piece you have to do at the end of the question. Okay, so we'll still do the same thing. It's still going to be negative 1 over 2. Okay, and then you bring down your 4, your negative 8, your 7, and your negative 11. Okay, draw the box down, draw the line over, and the 4 will still come down just like it always has. Okay, so negative half of 4 is negative 2. You get negative 10. Okay, negative 1/2 of negative 10 is positive 5. You get 12. Okay, and then you should get negative 6 when you do this, and negative 11, and negative 6 give you negative 17. Okay, so one of the things that we're throwing in as an addendum is the fact that this 4 never really gets divided by the 1/2 or used to the 1/2. And so if you did this problem, theoretically, when we rewrote the answer, you get 4x squared minus 10x plus 12, and then you have the remainder of negative 17. Okay? And this should be able to multiply by that and give you this. But it won't, because what's 2 times 4? It's 8. Okay? And so that's not the same thing. So what we have to do, the addendum part, is to come back at the end, and whatever the front number is right here, it's to divide each of these, not the remainder, just each of these by that number. Okay? And so the real answer will be 2x squared, and you're dividing by 2, minus 5x plus 6 with a remainder of negative 17. Okay? Alright? So we'll do a question. We'll see if you can get it right on the next one. I am actually going to pause it before I pull up the next screen. Okay? Okay. So given this one, this is your second example. Okay? I want you to divide this. Okay? So I just pause the video, and then you can come back and finish where we left off. So you got 5 over 2. You got 2, negative 9. Don't forget to put your 0. 15. And then you have your... Ooh. My hand got stuck. Okay, 2 comes down. Okay, so 5, this gives you 5 here. That's negative 4. So that's negative 2 times 5, which is negative 10. Negative 10 comes down. That's negative 5 times 5, which is negative 25. Just go back. That's 5. That's negative 4. That's negative 10. Boom. Just double checking my math. It should give you negative 10 as your very final answer. Okay? And then, to make sure we've done it correctly, we're going to go through and we're going to divide everything by 2. Okay? And so we got this 2 right here is what we're going to divide everything by. And you'll get 1, negative 2, negative 5, and then with a remainder of negative 10. Okay? And so that's x squared minus 2x minus 5 with a remainder of negative 10, or you could write it as negative 10 over the 2x minus 5. Either way is correct, okay? But from this moment forward, you're going to be expected to do this. I'm going to give you a quiz on this tomorrow when I come back. So you better have it. I will allow you to use your notes for this, and then when we do another quiz on it on Wednesday, I will not allow you to use your notes. But I just want to make sure that you guys understand that. So I'm going to give you one more question just to make sure you've got 3 examples down in your notes, so there should be no confusion whatsoever. Okay? And then we'll move forward. Thank you, guys. Okay, so this is your newest example. Go ahead and divide that out and then double check your solution at the end. Pause the video. Alright, now that you've had a chance to work it out, it should be negative 4 over 3 goes up here. Then you get 3, 0, negative 9, 6, negative 2. Don't forget the 0. Okay, so 3 comes down, you end up with negative 4 here, negative 4. And so then this gives you negative 16 over 3. Okay, oh, excuse me, positive 16 over 3. And so this would be the same thing as negative 27 over 3. Negative 27 over 3 plus 16 over 3 is negative 11 over 3. Okay, and then negative 11 over 3 times positive negative 4 over 3 is going to give you 44 over 9, and then that would be 54 over 9. Oops, 54 over 9. Okay, and then that will give you 98 over 9, and then you multiply by negative 4 over 3 to that, and that's going to give you 360 plus 32, 372. 360 plus 32 is 392, excuse me, negative 392 over 27, okay, and then that would be negative 54 over 27, okay, and that would be negative 392, subtract 8 from that, so it would be 450 minus 8 is 454 minus 8 is 446. Yeah, 446. So you got negative 446 over 27 is your remainder. Okay, and then hopefully you won't have anyone that's nasty when you take your EOC. But we'll take and we'll divide everything by the 3. Boom, boom, boom. Having your calculator, you should end up with x to the third minus 4 over 3x squared, and then this would be minus 11 over 9x, and then this will be plus 98 over 27, and then you'd have a remainder of negative 446 over 27. I know that got nasty, but you have a calculator that does fractions, and you should have no problems with that. Just double check my math. I might have done something wrong because I did it in my head, and it's 11:07 at night on a Sunday. Okay, so have a great rest of your day. Make sure you got all these down in your notes. And I will see you tomorrow. Thanks, guys.